Hello, my name is Christopher Appel, and today I'd like to talk to you about network virtualization within the NSX product. So as you can see here, I've got my vCenter loaded and I've got a VM built, but I'm going to show you a quick topology map. So within this topology map, and the goal of our exercise today is we're going to create a virtualized network environment with a single DLR and a single ESG. So that stands for Distributed Logical Router and Edge Services Gateway. We're going to use a couple of BGP ASs to accommodate that. What you need to be aware of is everything in this topology that's a colored object, green and blue, that all exists within one ESXi host for this exercise. And it's important to note that this is just demonstrating functional peering with an underlay or physical network, which is represented by this gray object up here. This is by no means a best practices configuration exercise, but it will give you a good idea as to some of the things that you need to look out for if you want to actually do this in a live production environment. And with that, we'll get going. So we got the basic vCenter view. I'm going to talk about the NSX components and the build pieces first. And then after that, I'm going to show you some gotchas and some very useful commands within the network virtualization building blocks to troubleshoot said objects. So in order to do that, we're going to go to networking and security. And what this video assumes is that you actually have a deployed NSX manager. So some of these original installation steps I'm going to breeze over. Based on the way I'm provisioned now, I'm not going to be going through these things, just a high-level overview. So you need to have an NSX manager affiliated with your vCenter. You need to have some NSX controllers built, and this is primarily because my zone is configured in unicast mode, which you'll see in a second. Host preparation must be complete, and the VXLAN must be configured. The logical network preparation is important. So again, just make sure that you see your VMK-NIC for the VXLAN P pool that you define here. And more importantly, if this was a live production environment, you want to make sure that this is affiliated with something in your underlay that you could actually get to. Because if VXLAN and VXLAN communication was occurring in multiple hosts, these things would need to talk to one another across the underlay in order to allow you to do the layer 2 over layer 3 communication. We got our segment IDs, and again, best practices, I'll mention it. If you're going to do a multi-vCenter environment, you want to make sure that if you're doing universal, that you have a universal segment ID pool. Segment ID is also synonymous to VNI, if you hear that terminology. And basically the takeaway is if you define a range on a vCenter, make sure that it's within a local range that is unique to that box, because one of the prerequisites is if you were to define the same range across numerous vCenters and then wanted to do something universally with them, pretty sure there's a write-up that states that one of the first things you would need to remediate is a segment pool that you've defined, which is your VXLAN information. So again, to save yourself some heartache, just make sure that that's unique per vCenter. And then you've got your transport zone. So the transport zone you can see is in unicast mode. And the takeaway here is this is going to be the zone that we're using for our logical switches. I'm not going to show you how to set any of this stuff up. It's pretty straightforward. You can click this add object, give it a name affiliated to the transport zone, and define the mode, and it will automatically assign a segment ID from the range that was explained earlier, and it will walk it sequentially. So in this particular exercise, I've got a VM that has been configured on the test logical switch, and we'll see that in a few. So the goal of this exercise, again, going back to the diagram, we're going to configure from the VM all the way up to the distributed logical router. Then we're going to define an IP address for our control VM. And then we're going to configure our edge services gateway. I've already pre-configured the underlay. So the .1 and the AS65K and associated information is here. If anybody's curious about what that information looks like, just so that if they wanted to do the piece of the underlay configuration as well to try this in their own lab, feel free to let me know and I will pass that information along. So let me show you what I've done with the VM first. The VM, I've used a CSR 1000V. I popped a console to this, and all I want to show you is a few basic things. I've configured an IP address on this, so it's 2.2.2.2, and if I take a look at my route, I've configured a static route for 2.2.2.1. If I go back to this diagram, that kind of highlights that the VM is .2, and the distributed logical router has a logical interface, or LIF, configured with .1 on this subnet. And it's a /24 network just to make things easy throughout the entire topology. So right now, if I try to ping this, it's not going to work, and we're going to demonstrate that right now. Now be aware, and we'll go through this as we do the distributed logical router configuration. It's not supposed to ping at this time because the object does not exist. So the DLR does not exist. That's why the ping is not working. Another reason why the ping might not work is if you had the firewall enabled on that box, and I'll show you how to deliberately shut that off as well. So let's start with the configuration of our DLR. So the DLR, you can see that I have one edge out here. Just ignore this for now. This is on a host right now that I have in a maintenance mode, so this doesn't apply. What I'm going to do first is I'm going to create the distributed logical router. The distributed logical router, you see a radio button here for the logical distributed router. All you need to know is that the logical distributed router optimizes east-west traffic, which is going to be our VXLAN traffic for our workloads within our software-defined data center. If I were to do north-south traffic, the parameter device going to the physical underlay network would be an edge service gateway. So let's give this a quick name. We're going to do the LDR first because this is what's going to be adjacent to our workload or our virtual machine, which is another term for it. And we'll give it a name, something not very interesting. We'll call it DLR01. And I'll just copy that information and put it in the host name. And what we want to do is we want to deploy an edge appliance. This kind of alludes to the fact that in order to support firewall or dynamic routing, we would need to have an edge appliance. This is actually what's going to spin up your control VM for your DLR. If you decided not to do this, and I did this in another lab, what you would realize is you wouldn't be able to configure dynamic routing. If you don't enable dynamic routing, configuring protocols like OSPF and BGP just is not going to work, so keep that in mind. We're going to click the next key, and again, I'm just going to define a strong password. If you define too weak of a password, it's going to give you an error message. I'm going to enable SSH access just to make it easy. Click the next key. Now what I'm going to do is I'm going to go into the edge appliance and I'm going to select my cluster. I'm going to select my data store. And host and folder aren't mandatory fields, but I'm going to click those just so you see me filling them out. I'm going to click the OK key. So everything's good so far. Now we've got our HA interface configuration. So we're going to put this on the transit interface. And we'll add our transit interface first, which is going to be our uplink. We'll connect that to transit. If we look at our diagram here, the transit is heading towards the edge services gateway, so our IP is going to be 3.3.3.1. Alright, and we're going to add one more interface here. We're going to add our internal interface, which is for our test logical switch. I'll show the diagram here in a second. So test is going to be 2.2.2.1 for the distributed logical router heading back down towards the workload. Alright, it's internal. And it's on the test logical switch, so that's good. We're going to click next, and we don't need a default gateway because we're going to be using dynamic routing. I'm going to click next, and then we're going to click finish. And right now we're just waiting for the VM to actually build. And I'll show you a few things that you need to do in order to configure the routing. And then we'll test connectivity from our workload to the distributed logical router to ensure that that piece is working. Okay, so we're just going to click refresh here and see if this is done. It still says busy and it's still spinning here, so just wait a little bit. Okay, so if it's healthy, you should see it in a deployed state, so that's what we're going for. You see that it lists a logical router. If we double click on this, it's going to open up some additional information. If you want to validate your interface information, you can click on interfaces. Interfaces is going to show you the local IP addresses of both boxes, as well as an interface with an uplink type, which again should always head towards your transit interface from the DLR to the ESG. And you've got a test interface, which is heading down towards the workload, which is internal. So all of this stuff looks good. You have a green check mark indicating that the NIC here is connected, which if you weren't sure about that, you could click the edit key and you would see the connected status right here. So that's kind of a good visual indicator that that's connected. What we're going to do is we're going to go to the firewall, and you can see that it's enabled right now. I'm going to disable the firewall and publish that. And then we're going to go into the routing information and do that really quick. And that'll explain the VM and how it's actually configured to communicate to the DLR and kind of show that process. So we're going to start under global configuration. And we're not going to do ECMP in this exercise, but this would be useful if you wanted to increase the amount of bandwidth and your default routes coming out of your distributed logical router. Useful if you have a number of edge service gateways up to a maximum of 8. We're going to take our transit interface, which is our uplink, and this is always the first piece. You always need to define a router ID. If you don't do this and you try to go into the subsequent windows, what you're going to notice is it's going to give you errors. So just keep that in mind. We're going to go into BGP and we're going to click edit. I'm going to disable Graceful Restart and just enable BGP for now. We're not going to play with the default information originate here, and the main reason is because we're going to be actually learning that and not originating it within the environment. We're going to be learning it from the underlay, so this is not required. But what is required is the BGP autonomous system number that we are a part of, and you can see that that's 65001. Okay, so we're going to publish those changes. And then the next change that you need to make is the neighbor relationship. So here's where things get a little bit interesting. When you see IP address, this is referring to the remote IP address that you're going to be peering with in your edge service gateway. So let's take a look at the diagram again. You can see that our transit, we're locally .1, and the edge service gateway is .2. All right, so we're going to peer with .2. 3.3.3.2. The forwarding address is always the IP address of our logical interface. And again, if you take a look at the diagram, you'll see that that's 3.3.3.1. So the terminology is a little confusing. If for whatever reason you mess the forwarding address up and it wasn't an interface that you actually created, you will get an error message. The protocol address is going to be the control VM. The control VM is going to be what's responsible for doing the BGP peering with the edge service gateway. So you can see that that is 3.3.3.100. And the remote AS, once again, the edge service gateway and the distributed logical router are all going to be within BGP AS 65001. Weight we're not going to mess with. We'll keep the keep alive and the hold down, the values that they're at right now. Just be aware that if you were in production, you'd probably want quicker convergence. So if you want to see what that would look like at the best timers, I guess I could change those. We can make those 1 and 3. Best practice is that it must match on the peering. Have desirable results. So we're going to click OK, and we're going to publish those changes. So once again, if you're playing this back, the forwarding address is the address of the local box. The protocol address is the address of the control VM. The IP address is the remote IP that we're peering with. So all of that's summarized here once again. Now we're going to go to route redistribution. This step is important because if you don't redistribute your connected routes, you won't receive the advertisements. So I'm going to show you how to do that. Right now you can see in the summary we've got a green check mark next to OSPF. We're not using that, so we're going to turn that off. We're going to turn redistribution on for BGP. Okay, we'll publish that change really quick. And just to keep things very easy, and again, not a best practices type of deal here, but I'm going to click the plus button down here, and I'm going to say, I want to redistribute connected routes, any prefix, into BGP. Very self-explanatory. I'm going to publish those changes. I'm just going to clean up OSPF down here. And this completes the configuration of the distributed logical router for this particular exercise. You'll see that I have another network down here for prod and whatnot. I don't have a VM built on this right now, but this will fully demonstrate communication from your network virtualized environment by the time we're done to the physical underlay, which is the goal. So now let's back up a little bit, and I'll go back into my VM because we turned the firewall off. And I'm just going to ping my default gateway just to see if this works. So that's a good sign. So that means that the distributed logical router to the workload, or again virtual machine, because they're synonymous, is successful. So that's a good first start. We're going to take a quick look at the virtual machine and just show you, because I already showed you the VM configuration of the virtual router, but what you're really going to care about is the host itself. So if I go to the virtual machine and click on CCIE2, what we're looking for here specifically is to make sure that the network adapter that I've configured is on the test logical switch. Because again, this network adapter would be the logical switch that is being used and connected to the distributed logical router. You can see that I've connected the other 3 adapters to prod, but just keep that in mind. I've configured network adapter 1 as being on the 2net, and the 2net is configured to receive that as our logical interface or LIF. So let's complete this configuration. Let's go back to our network and security. Okay, and we're going to stay right in NSX edges. And I'm going to click the plus sign again. This time we're going to create an Edge Services Gateway. The Edge Services Gateway, again, anticlimactic. We're just going to call it ESG01. Host name is ESG01, and we'll keep the values at default. Define our lengthy password again. And we'll enable that. We'll click next. We'll do compact, and I'll fill all these values out again. Click next. And it says, okay, what interfaces are on this? Now this is where things change a little bit. So where the distributed logical router was an uplink interface because it's heading north, the Edge Services Gateway on the transit interface is heading south. So on the Edge Service Gateway, this is an internal interface. We'll still call it the same thing though, just to keep in mind just the basic names that we've decided to use. It will make this transit. And we're going to take a look at our diagram, and we can see that we have an IP address of 3.3.3.2. So we'll configure that really quick. And a mask of 24. Make this 1600 and click OK. And then we're going to configure our uplink. Now this uplink is going to go to the physical network. So since it's heading north, it is an uplink. So we're just going to say uplink to core. In the particular distributed port group that I'm using for this is going to be CCIe switch 1 to ESG 1, which is what we've configured. I just configured this ahead of time with an appropriate VLAN tag, and again, all the underlay stuff is already configured. And we'll set this to 1600 and click OK. So now we have the two interfaces that we need, except needs an IP address. That's mandatory. So we're going to go up here, and we see that our uplink going to the physical underlay is 4.4.4.2. Now keep in mind, I just chose arbitrary IP addresses. Yes, this is in the public IP space. I've got it basically isolated from the rest of my environment, so you probably wanted to use RFC 1918 space for this. Since we're in a lab, we could pretty much do whatever we want. Okay, once again, not configuring the default gateway. We'll skip the firewall, and we'll click Finish on the Edge Service Gateway. And now we're waiting for this to deploy again. So keep in mind, when you deploy the DLR with the control VM in the Edge Service Gateway, that's going to create virtual machines that are going to show up in your host inventory, which I'll show you here in a second. Wanted to complete and turn the firewall off on this first, complete the BGP configuration, and then I'll show you where those VMs actually live. Okay, deployed, so that's good. So once again, we're going to double click on this. Just start with a firewall. We're going to disable this, publish. That way, if we're trying to ping between devices, we don't need to worry about ICMP dropping things. Once again, we can go into Settings Interface, and you will see your two interfaces, one heading towards the distributed logical router and one heading towards the Edge Service Gateway, both connected. Now we're going to go into routing, and routing is very, very similar to the distributed logical router. So we're going to breeze through this. Once again, it knows my uplink interface, so it's going to select that router ID. So we'll make that the router ID. And sometimes in my lab this happens. I'm not exactly sure why, but I click it again, and then I get the publish changes that you should see. But yep, we obviously want to publish those. Again, not messing with ECMP. We're going to go into BGP now. Click Edit. No graceful restart. Enable BGP. And the local autonomous system number in common, we're going to do iBGP south. So click that. Just show you the diagram really quick. So once again, we're still in 65,001 here. Now we're going to add the neighbor. So we're going to add the neighbor going south first. The IP address here, super important. This does not go to the logical interface on your distributed logical router. The peering occurs between the Edge Service Gateway and the control VM. So the IP for the peer we're going to define is going to go to 3.3.3.100. This is something that changes a little bit from the physical underlay. So if you come from a network engineering background, that may seem a little strange at first. But just be aware that it's because they decouple the control plane, which is what we need to peer the routing protocol, in the data plane. So once again, we're going to define that as 3.3.3.100. And the remote AS again is 65001. And we'll drop those timers because we did for the other one, just to keep it consistent. We'll click OK. We'll publish that change. But in this particular case, we're not done yet. And it's because this particular device has two BGP neighbors. It's going to have a BGP neighbor between these two devices, and it's going to have a BGP neighbor to the physical underlay up top. The remote AS for that particular box is 65,000. So let's take care of that really quick. The IP address of the remote is 4.4.4.1. And once again, the AS is 65K. And we'll be consistent and get the fastest convergence times you can get, 1 and 3. And click OK. Publish the changes. And we're almost done. So if you can remember the last step from the distributed logical router, again, we wanted to redistribute the directly connected. So we're going to redistribute to BGP. We're going to publish that. And the route redistribution, I'm going to say connected routes to BGP. We're going to publish. So this should be enough to satisfy criteria at this point to peer with the physical underlay and the distributed logical router. But really quickly, let's go show you really quick in the hosting clusters the two virtual machines. So you can tell that this is the control VM because this has the IP address of 3.3.3.100, which is our control VM. And then you got your edge service gateway. So now what we're going to do is we're going to actually open these things up. So I'm going to click this to pop a console. And this is the same password that you defined in the setup of the box, that lengthy password that we had to do. So we're going to log into this really quick. Okay, so we're on this box. And what we're going to do really quick is a very basic troubleshooting command for BGP. When you run this command, it's going to show you the upstream IP address, which is 3.3.3.2 in this particular example, and the BGP state that you are looking for always should never ever deviate from this, should always be this, established up. If you see active, if you see connected, if you see idle, those are all bad codes. Established up is what you were looking for. Other thing to take away also is that BGP uses port TCP 179. So TCP 179 would have to be allowed in order for this peering to occur also. So just keep that in mind. But the takeaway is we have a good BGP neighbor. What we're going to further do to evaluate things is we're going to type in show IP route. And you're going to notice a few cool things here. So you're going to notice a B for any BGP learned route. So you could actually see that we're learning a default route, which is a good indication that we're actually learning things appropriately from the physical underlay. So big thumbs up there. It means we're doing something right. And we're also learning the BGP route of 4.4.4, which is the networking common between the physical underlay and the edge service gateway. And that's mainly because we just redistributed the connected routes into BGP. So if I try to ping 4.4.4.1, which is a physical underlay, I should get a response. This will prove that communication to the physical underlay is good. So let's try it. And we're successful. From the VM, we try to ping the physical underlay once again. It is successful. We're going to go pop the console for the edge service gateway now. And once again, log in with our lengthy password. Okay, same commands apply. Show IP, BGP, neighbor. Two neighbors, all right? 3.3.3.100, edge service gateway to the distributed logical router control VM. Established up, that's a good code. BGP neighbor 4441 going to the physical underlay, established up. So again, a good code. Type in show IP route. And you can see that we're learning a default route from our physical underlay as eBGP. And you could also see that we're learning 2.2.2 as the logical switch between distributed logical router and our CCIE router VM. So I'm going to ping that really quick, drop this down so we can actually see what we're doing here. You can see that I can ping the workload, so that's good. Should also be able to ping the other side of this connection. I'll happen to ping something northbound that I should just follow default to get to. And you can see that I can ping that as well, so we're good. If you wanted to get more granular and just look at the BGP routes, you could type in show IP route BGP. So if you don't want to look at all the other routes and just look at those, that'd be good. You'll see these numbers here next to the routes. Next to the default route, you'll see a 20/0. You may hear that called metric. You may also hear it called administrative distance. This is a value local to the box. The only takeaway that you really need to take away from what you see here is if you see 20, 20 is eBGP, meaning the ASs are different between the 2 points. And when you see the number 200, that's a default value for iBGP. Mileage may vary. Arista networks have actually noticed eBGP as showing up as a value of 200, but the value of 20 being external and 200 being internal for BGP, that's consistent across Cisco equipment, just if you're curious. We're going to take a look at our physical underlay really quick. And this is what we happen to be peering with, so I'll type in show IP BGP summary on switch 1. My inactive edge right now, and you see a status code of active. Same thing applies in the physical underlay. If you don't see prefixes exchanging or whatnot, it means you're not in an established state. So even if you see prefixes as 0, you're established. But the takeaway with this command is you could see my router ID, my local AS, and my neighbor IP address. So this is my edge service gateway right here. And you can see that it's been active for about 7 minutes. I'm going to try to ping the VM that I have in the environment. And you can see that it's 100% successful. Send 1,000 ping packets at it. And we are good. So I hope that bridges the gap a little bit for people that have more of a networking background that are looking to do networking related concepts within NSX product where it's released, which is wonderful. So I hope you learned something from this, and if there's anything else you'd like to see, and talk to you soon. Hope you had fun.